1.9, solving equations by multiplying or dividing. We just did solving equations by adding and subtracting, and this is very similar. You can solve a multiplication equation using the division property of equality. Just like with addition, we had to undo that addition on each side of the equal sign. With multiplication, we have to undo the multiplication or use the inverse operation, which in this case would be division. So if I have something like 4 times 3 equals 12, I can divide both sides by 2. It's that balancing act, teeter-totter, and as long as whatever I do to one side of the equal sign, I do to the other, it will still always remain true. So here's an example. Solve 6x equals 48. What's being done to my x, or my variable? It's being multiplied. So to undo that multiplication, let's divide using the division property of equality. So both sides divided by 6. 6 divided by 6 is 1. That's what that division property of equality means. So I'm just left with 1x. That 1 in front of the x is arbitrary. It's one of those things that's always there. We just don't see it written in math, but it's always okay to put there. So I can take that 1 out. X equals 8. I can put that back into the check just as we did with addition and subtraction. Substitute 8 in for x. 6 times 8 is equal to 48. Another example, we have to remember our rules for positives and negatives. Negative 9y equals 45. So what's being done to y? It's being multiplied. So I'm going to use the division property for equality and divide both sides by negative 9. So negative 9 divided by negative 9 and 45 divided by negative 9. Two negatives divided is a positive, so that's going to leave me with positive y, which is good. I don't want a negative y or a negative variable. I always want to solve for a positive variable. And on the other side, 45 divided by negative 9 is going to be negative 5. Again, there's that 1 in front of y. It's arbitrary. I can use my identity property to go ahead and get rid of the 1. So y is equal to negative 5. Let's do a quick check with that. Substitute negative 5 in for y. Negative 9 times negative 5. Same sign, positive answer, 45. You can solve a division equation using the multiplication property of equality. So if a variable is being multiplied by something, to undo that multiplication or the inverse of that would be division. So vice versa. If something's being multiplied, the inverse of that is division. Okay, solve. b divided by negative 4 equals 5. What's being done to b, or my variable? It's being divided by something, so I need to multiply by that same something. So if I multiply both sides by negative 4, it's like that negative 4 goes up in the numerator and it can reduce out. So both sides by negative 4. On the right-hand side, negative 4 times 5, a negative times a positive different sign is going to be a negative. b equals negative 20. I can go ahead and plug this in as a check. Substitute negative 20 in for b. Negative 20 divided by negative 4, same sign, positive answer is 5. Where might I see this on an application? To go on a school trip, Helene has raised $670, which is 1/4 of the amount she needs. What is the total amount needed? Okay, well, she has raised a fraction so far, right? She's raised 1/4 of the amount she needs. I don't know how much she needs total. I just know that so far she's raised the $670. So there's my plan in those colored boxes. Now I'm going to assign the numbers to my plan. I don't know how much is needed, and I have my answer on that other side. So what's being done to x? It's being multiplied, but it's being multiplied by a fraction. So how can I get rid of a fraction? I could move that variable up into the numerator of my fraction, and then it looks very similar to a division problem, and I'll show that in class tomorrow. The other way to think about it is multiply whatever is in the denominator, and that will reduce out to 1. So if I multiply my left-hand side with my 1/4 times 4, make sure I multiply the right-hand side by 4. So 1/4 times 4 is just 1. I can take that 1 out. X is equal to 2,680. So Helene needs $2,680 total. Since it's a word problem, please make sure to include the proper units and labels. And then I could just do a quick check. An estimation would work for a check on something like this, or you could go ahead and plug it back in using substitution. Sometimes it is necessary to solve equations by using two inverse operations. For instance, the equation 6x minus 2 equals 10 has multiplication and subtraction. We need to follow order of operations. However, when we're solving for a variable, we're actually undoing what's been done to the variable using inverse operations. So I use inverse order of operations is how I think about it. So if you write PEMDAS at the top of your paper to solve just a regular expression or equation, you're going to work backwards PEMDAS, so draw an arrow going the opposite direction to solve for a variable. So I've got multiplication, I have subtraction, I have to undo all of that. So there's my variable term. To solve this equation, add to isolate the term with the variable in it. So I'm going to isolate my variable first and then divide after it's isolated into a single term. So let's look at an example. 3x plus 2 equals 14. I have multiplication and I have addition that I have to undo. So step one, we have to undo the addition first. Remember, backwards order of operations. So to undo addition, let's subtract both sides by 2. That gives me a 0, which is arbitrary. I don't have to write that in there. I'm left with 3x equals 12. So now that I have my variable term isolated, I can undo what's being done to it, which it's being multiplied, so let's use division to undo that. Divide both sides by 3. X equals